Unraveling Zeno's Achilles and the Tortoise Paradox, a 2,500-year-old puzzle solved. Zeno of Elea, a pre-Socratic Greek philosopher, presented a series of paradoxes that have challenged and intrigued thinkers for over 2,500 years. Among these, the paradox of Achilles and the tortoise is perhaps the most famous. Zeno's paradox goes as follows. Achilles, the fastest runner in ancient Greece, challenges a slow-moving tortoise to a race. Out of fairness, Achilles gives the tortoise a head start. Zeno argues that Achilles will never be able to catch up to the tortoise, no matter how fast he runs. Here's why. Achilles allows the tortoise a head start. Let's say the tortoise begins 10 miles ahead of Achilles. To catch the tortoise, Achilles must first reach the point where the tortoise started, 10 miles ahead. However, by the time Achilles reaches that point, the tortoise has moved forward, perhaps by 1 mile. Achilles must then cover this additional distance, but by the time he does, the tortoise has moved further still. The paradox. Zeno contends that this process repeats infinitely. Each time Achilles reaches the tortoise's last position, the tortoise has advanced slightly further. This infinite sequence of tasks implies that Achilles will never actually catch up to the tortoise, because there will always be another distance to close, however small. Zeno's paradox is so robust that even if Achilles could move at a huge but finite speed, he would still be chasing the position the tortoise occupied at the start of his movement. The logic of the paradox dictates that Achilles would always arrive at where the tortoise was, but not where the tortoise is. Thus, even with great speed, Achilles could never actually reach the tortoise, because the tortoise's position is always shifting forward. Despite the simplicity of this scenario, it has challenged mathematicians and philosophers for millennia. However, as we will demonstrate, the paradox, when considered as a puzzle or a riddle, can be resolved definitively by careful consideration of Zeno's assumptions. In this video, we will provide a clear, logical resolution to Zeno's paradox. We will show that Zeno's conclusion about Achilles and the tortoise is basically correct because of the specific conditions that Zeno imposed on the problem. The first major attempt to solve Zeno's paradox came with the development of calculus. Mathematicians realized that the infinite series of distances Achilles must cover to reach the tortoise could be summed to a finite value. In the infinite series solution of calculus, the infinite steps of the pursuit are seen to achieve a limit value in which Achilles reaches the tortoise. But Zeno requires Achilles to move toward the tortoise's original position in his statement of the question, i.e., the position of the tortoise when Achilles begins his move. This assumption is made clear by the claim that Achilles could move at any speed and still not reach the tortoise. The series solution, as usually presented, does not properly handle that requirement. Using what we interpret as Zeno's assumption, that Achilles is always pursuing the position where the tortoise was at the start of Achilles' move, we can demonstrate that Achilles will never overtake the tortoise. Let's analyze the situation further. According to Zeno's argument, Achilles will never catch up to the tortoise because he is always aiming for the position the tortoise occupied in the previous step. However, if we consider this in more detail, we see that as Achilles continues to chase the tortoise, each step brings him closer to the tortoise. Over time, the gap between them becomes smaller and smaller. Eventually, Achilles becomes arbitrarily close to the tortoise, so close, in fact, that the distance between them can be made as small as we like. Despite becoming extremely close, Achilles is still bound by Zeno's rule. He must continue to aim for the position the tortoise previously occupied. Even though Achilles is now very close to the tortoise, he is at times even with the tortoise and at other times just behind because he's following the tortoise's past position, not overtaking it. The tortoise, however slow, continues to move forward. Because of this, even though Achilles is right behind the tortoise, arbitrarily close, he can never actually take the lead. This leaves the tortoise always slightly ahead at least part of the time, even if only by an infinitesimally small margin. Here's the breakdown of what might happen in reality. Here are the parameters. Achilles' speed, 20 miles per hour. Tortoise's speed, 5 miles per hour. Achilles has a reaction delay of 1/2 second, meaning he waits 1/2 second before he detects and reacts to the movement of the tortoise. The tortoise has a 10 miles head start, and the total distance is 20 miles. We'll focus on the 1/2 the second gap in terms of miles here, not the total distance. Since Achilles waits for 1/2 second after the tortoise starts moving, the smallest possible gap between Achilles and the tortoise will be the distance the tortoise can move during that 1/2 second reaction delay. Converting the tortoise's speed from miles per hour to miles per second, we get 0.0014 miles per second. This means that during the 1/2 second reaction delay, the tortoise moves approximately 0.007 miles. Due to Achilles' 1/2 second reaction delay, the tortoise will always be at least 0.007 miles ahead of Achilles. This is the smallest possible distance between them that Achilles can never fully close, no matter how fast he runs or how long the chase continues. The 1/2 second delay is an exaggeration of the fact that there must be some delay between the movement of the tortoise and the movement of Achilles. This being the case, we see that the usual series solution does not address the question. For though it correctly claims that Achilles reaches the tortoise if we ignore the reaction time, it implies that Achilles wins the race. The usual series solution assumes that Achilles continuously moves toward the current position of the tortoise at constant speed, with the intention of overtaking it, not move toward the position of the tortoise when Achilles begins to move. Both strategies indicate that Zeno's paradox depends very much on the precise statement of the question, i.e., the precise pursuit strategy. But Zeno was making a point about the impossibility of motion. With his precise statement, he claimed the idea of motion led to paradoxical consequences. However, by changing our pursuit strategy, the idea of motion loses its paradoxical character. The Achilles and the tortoise paradox hinges on the specific pursuit strategy Zeno described, one in which Achilles always aims for the tortoise's last position. It does not require Achilles move at constant speed. Under these conditions, Achilles can never do more than catch the tortoise for a moment, then fall behind again. We can't quite say that Achilles doesn't catch the tortoise. He may, but we can say that he does not win the race. However, if we alter the pursuit strategy, such as by aiming for where the tortoise will be, Achilles can indeed overtake the tortoise and win the race. Thus, the paradox does not truly exist, since it is not at all a general result. It is a result of the specific, somewhat artificial conditions Zeno imposed. When we explore alternative, more realistic strategies, the paradox dissolves. Zeno's Achilles and the tortoise paradox has puzzled thinkers for over 2 millennia. However, by carefully analyzing the conditions Zeno set forth and exploring alternative strategies, we can see that the paradox is not so paradoxical after all, in that we can completely understand what takes place by looking at the pursuit requirements.